The Field of Miracles in Pisa has three major sites: the Tower of Pisa, the Cathedral, and the Baptistry. Of the three, it's the Baptistry that has caught me the most. These next videos are an exploration mainly around the Baptistry. This video is a journey into the possible geometry of the Field of Miracles. Note that this video is based upon Google's satellite maps, so please bear in mind the limitations of the accuracy of the measurements. From a previous visit, the north door and the east door are on the north and east axes, so the centre of the baptistry can be approximated. Having spent some time testing various options, select two other points. Measure out the length of the cathedral's aisle and put it to one side as the basic unit of measurement. Connect the points to trace out a triangle. Using the measure, it can be seen that the base is 2 units long, with one of the other sides 1 unit long. Copy, flip, and align. Again, copy and flip. Using the measure, it shows that this is a 6-sided figure or hexagon, where the sides are the same length as the length of the aisle. Remove the triangle and replace with a hexagon. There is an understanding that if a physical cross is north-south, east-west, then the essence or unseen aspects can be shown as a solar cross. As the baptistry is 12-sided, it suggests that the hexagon can be copied and rotated 30 degrees to represent an essence or unseen aspect of the hexagon. When this is done, two things happen. The front end of the cathedral aisle is fixed, and more interestingly, it highlights another triangle. Half A, and the square root of 5A divided by 4. Both points arise once the unseen or elliptical hexagon has been added. This hints at the golden mean, as the square root of 5 divided by 4 plus a half equals approximately 1.6180, which equals 5. And it also hints of the pentagram. Going back to the original triangle, because we now know that it is an element of a hexagon, then as the first line is the length of the aisle, and the second line is twice the length of the aisle, then the remaining line can only be the square root of 3 times the length of the aisle. Whilst it is impossible to put a number to the square root of 3, it can be drawn quite easily. Draw a horizontal line and draw a circle centered on the line with a radius of A. Then, at one end, draw part of the same circle, and where they intersect, the sides of the triangle can be traced out, given the lengths A, 2A, and the square root of 3A. Copy the triangle and drop the copy. Align with the bottom length to the right. Then the difference between the ends of the triangle on the left will be 2A minus the square root of 3A. Using this difference as the radius of a new circle, draw in the 12-sided polygons and the hexagons over the circles. Matching this with the site, there is a reasonable fit, with the added bonus of linking the statue at the southeast entrance of the Field of Miracles. There also seems to be a connection from the baptistery to the Tower of Pisa. Drawing a line from the top edge of the baptistery through the centre of the large circle to the centre of the Tower of Pisa. Then, putting in a picture of the baptistery, the second floor and the first floor windows descend by about 15 degrees, which matches the red line. Could this be the basic design of the Field of Miracles? Could it be that field observations of the stars would be fine-tuned in the baptistery? The next video will be looking at this.